joined by William Messner. William is the founder and CEO of PonyPak Systems, and he's going to be discussing with us disruptive life support technology for professionals operating in extreme environments. There it is. You there?
There we go. Yes, I am. Thank you very much. I appreciate having an opportunity.
Welcome, William. We look forward to your presentation on PonyPak here. Let me turn it over to you.
Thank you. Appreciate the opportunity to present to you and to the other people who are on this call. I'd like to share the screen very quickly here, and hopefully, there we go. Let's get screen 2. There we go. That would be up. Can you see the screen?
Success.
Yes, you can?
Yes.
Okay. All right. That's great. Glad to hear it. PonyPak Systems has developed all new technologies for delivering life support to people operating in extreme environments. Extreme environments meaning hundreds of feet underwater or hundreds of feet in confined hazmat environments. And because this is the work and the operations and where people work, most people have no awareness of. I've got a little presentation here that kind of helps people understand the environments that people are working in. This includes all your military, commercial, industrial, municipal, transportation, scientific, and educational markets. So it is multiple markets. It includes the maintenance and inspection of municipal infrastructure, meaning water, sewer, utility mains, dams, potable water towers. Includes all structures that containers, vessels, and industrial complexes that either manufacture or transport hazmat materials, whether it's by road or rail, ocean, or even air. It also includes all ships, commercial, passenger, and military, the husbandry, the maintenance and inspection, both inside of the ship and, of course, externally to the ship. And so to help people visualize this, we've got a short little video that will give the 30,000-foot level introduction. My name is William Messner, and I'm founder and CEO of PonyPak Systems. Both military and first responders operate in extreme environments, including confined hazmat spaces. This includes all stages of operational infrastructure, from initial construction to ongoing maintenance and inspection to search and recovery. Current life support technology is ancient. It was invented by Leonardo da Vinci in 1500, and except for materials, is unchanged since World War II. It is extremely limited, decades beyond its design life, and cannot support even the most basic technologies that are readily available in every other industry. A total solution for this challenge requires a completely new, infinitely upgradable operating platform. PonyPak Systems has developed the first rapidly deployable plug-and-play technology to integrate and deliver all life support services to people operating in any extreme, confined, or hazmat environment, terrestrial or subsea. It's supported by 50 patents in 30 territories. As seen in our patent drawing, our solution is an operating system. The first iteration of our solution includes breathing gas, a safety tether, 1080p video, bidirectional audio, GPS, plus ancillary circuits to power lights and tools. It includes real-time integration of remote SMEs. It supports body-mounted sensors for real-time monitoring of human biometrics and environmental CBRN. It will support the integration of heads-up displays, virtual reality, and artificial intelligence. It will support dynamic thermal protection for heating or cooling within their hazmat exposure suit. All this capability is deliverable through a single micro-umbilical the size of your little finger. It is smaller than the gas-only line shown here. 300 feet coils onto a deployment reel only 2 feet square that is easily transported by a single person. A complete 4-person life support system can fly as regular luggage on a commercial airline. The solution must be universal and operate in any confined hazmat space, including tankers, ships, pipelines, and industrial complexes. The current technology is old, bulky, and costly to operate and transport. Large diameter, gas-only umbilicals are difficult to handle. The safety tether and audio are separately managed lines. Real-time video and all other technologies are non-existent. EOD operators consume half their air supply walking hundreds of feet to and from their staging areas. With no wireless audio or video comms, they must carry complete analytical instruments, then struggle to operate them instead of hands-free, body-mounted sensors that are remotely monitored, analyzed, and reconveyed through audio comms. Absent thermal cooling or vital sign monitoring, technicians are pushed to their physical limits carrying 100 pounds of life support and body protection. Absent distributable AV communications, remotely located decision decision makers cannot document or communicate in real time with operators who are in situ. And with a system solution that is infinitely upgradable, scalable, rapidly deployable, and easily reconfigured simply by plugging and playing the required technology. Our first generation accepts any high-pressure gas source. The 6-pack cascades 6 swappable carbon SCBAs for unlimited air, or you may use a high-pressure compressor. The gas pack accepts any source up to 6,000 psi, then reduces and distributes it to up to 4 technicians at any stable user-defined pressure over 800 psi. The reel pack accepts the gas on one side and all power and data communications on the other. 300 feet coils onto a single spinnable reel. The VDC pack accepts 1080p video plus analog audio from 4 technicians. It digitally removes the breathing sounds from a full face mask audio comm. Video, audio, and GPS are mirror recorded on solid-state drives. It converts any 2-channel audio comm to 4-channel and bidirectionally broadcasts via 4G, 5G to any computer, tablet, smartphone anywhere. The PowerPak provides switchable power circuits and operates as a UPS with available AC power. Dynamic thermal protection is deliverable through electrically heated undergarments and for cooling through a proprietary new technology now in development. Body-mounted CBurn and biometric sensors may be monitored and distributed in real time through our VDC pack. The data pack integrates digital technologies, both current and future. The system allows remote medical or structural SMEs to communicate and advise through the real-time eyes and ears of a technician deep inside a confined hazmat space, or a salvage diver, or a submariner, or the hazmat maintenance of a commercial or military ship, or to dynamically cool a hazmat technician within his exposure suit. We can provide 100-foot visibility to divers operating in black water by integrating mask-mounted sonar for real-time conversion to video and viewing on in-mask Google Glass. Our new operating platform radically improves the maintenance and inspection of municipal infrastructure and military and first responder search and recovery operations in any environment. That includes science, education, renewable energy, and even NASA. We've had multiple requests for our disruptive new technology from every military branch. Our platform scales from 1 to 4 people. All systems and technologies are plug and play and equally scale according to need and budget, including a truck that is fully configured for both terrestrial and maritime operations. The complete solution to this challenge is a system solution. It starts with a micro-umbilical with breathing gas and tether and bidirectional communications, and will extend with the continued development of new safety systems and work efficiencies that will be developed by third-party companies. PonyPak system is not a new single application technology. It is a highly disruptive suite of technologies for an entire global industry. It has and will continue to spawn a vast array of new technologies created by a multitude of other companies to improve, simplify, and increase the safety of everyone who works in extreme environments. Terrific. As you can tell, this is not a single product or a single service or a single app. It's a complete suite of technologies that operate together as a system. And the innovation is not the hardware, although there is innovation in the hardware. The current technologies, the umbilicals for underwater, are 2 inches in diameter. They are gigantic. They require military commercial transport, and I'll have a few images coming up in a minute. We've shrunk all of that down to an umbilical that's literally the size of your little finger. And in that, you've got high pressure breathing gas, 1080p video, an independent tether, 5,000-pound test, and all kinds of additional services that all coils onto a very small reel. And the concept is to create an operating system. Right now, all of these markets, and the best way to describe it is for going back to maybe people who remember what it was like to use a manual typewriter. When the Mac came in and Windows came in, it did not replace the manual typewriter just because it could do a letter better than a single font on a piece of paper, a file cabinet, and a fax machine. It was because the Mac could do 100 other things that a manual typewriter was structurally incapable of doing. That's number one. The other reason why I changed it is that people who use typewriters were used by different industries. You had the graphics industry, film industry, accounting, typesetters. Every industry was completely separately siloed, and they had their own systems for being able to work in those industries. what the Windows and the Mac did is come into those industries and said, look, at all of you are no longer in those individual industries. You are all in the information management industry. And guess what? Your information management now can all operate on our single operating system. So the innovation was not the box, the screen, the keyboard, and the mouse. The innovation was that it was a single operating system that could manage all of the information that every industry operates upon. And so that's in essence what we've done here. Let me move the screen forward. So our patent, if you look at it, this is the only drawing for our patent, and there's no hardware in the patent. It is an operating system, and that's the part that people oftentimes struggle to take a look at and see. It's not hardware. The hardware is going to grow and change and develop, and third-party companies are going to come in and attach their hardware to it based upon a new operating platform that we've created. And this is what it looks like with the first iterations of the hardware. Now, all of this is going to change in time as companies come in with their systems and want to integrate their services and make it finally deliverable for the first time in many instances to people who are operating in these extreme environments. So I'm going to key on just a few simple examples of these. You've got people operating extreme environments. You can put sensors on them. You can have biometric sensors. You can have CBRN, which is chemical, radio, environmental toxins. Sensors, instead of having complete instruments, you can just have the body-mounted sensors. All of that data then can go through the umbilical and then be shown on displays to the people who are the tenders, who are servicing the technician, and can monitor the body, can monitor the environment, can monitor any IP data that might be coming up the umbilical. And then that can be then displayed and put over into our VDC pack. Now, the VDC pack not only can take the video and the audio and GPS, and it can also, with additional channels, take all the biometrics, CBRN, any other IP data that is coming in, and that can be recorded. And that through 4G can be bidirectionally 5G through the internet to any PC, laptop, smartphone, anywhere. So I'll give you an example of how this might be used. You can have divers who are working off, instead of barges, a small inflatable, doing an inspection of a ship in New York Harbor. They see something under the hull they don't like. They can call up the owner in Europe. He can open up a cell phone, see, hear, and talk directly with the divers in real time, see what the issue is from the perspective of the diver, and then be able to make a decision. And all those decisions are all recorded both locally and in the cloud. So it's the very first time we can bring in mass communications and documentation and sensors in real time with the people who are operating in these environments. Give you another example. One of the most important safety features for divers, and I'm going to concentrate mostly on the underwater applications, although our biggest markets are really all the terrestrial, is to be able to see. Air is most important. The ability to see would be second most important, because most of these people are working in zero visibility environment. They can't see their hands in front of their face. And so the way we can overcome that is by taking two technologies that currently exist, but are not operable in this environment. And what we've done, except for now with our infrastructure. So we can take a small micro sonar head that first of all can be put on a pole mount. Whoops, let me go back. On a pole mount to do a broad area target search. Once they found the target, then they can put the sonar head on the diver's mask. That sends raw sonar data up the umbilical to their surface module that converts it to a visual image. You send that image back down the umbilical to the diver, and the Navy's already developed what they call as DAVD, which is basically Google Glass inside a full face mask and helmets. And with that, you can give 100-foot visibility to a diver who, in fact, is in zero visibility water. That's a complete game changer for people operating in these environments. Another example is heat. Right now, divers who are working in extremely cold waters, doesn't have to be under the ice. Water at 30 degrees is very cold, even though there might not be ice. Right now, they use hot water systems, which is a big rubber suit. These are the current umbilicals. You can see how massive they are and how we have reduced them. But these systems use hot water. So they boil hot water, send it down big hoses. It's hot where it comes in. It's cold on the hands and feet. It's gigantic, cumbersome, and ancient technology. Right now, we convert that to Sati makes electrically heated undergarments, and they've agreed to develop the surface systems that can power an electrically heated undergarment, controlling the body temperature at the extremities with the core. That's done through the umbilical, powered from the service. Obviously, this is something that's very simple to easy, plug and play, much easier to transport, use, and far more efficient. So this is examples of how our infrastructure allows these technologies to finally be deliverable to the people in these environments. Same thing with power. You can have all kinds of additional accessories that are on the technicians that are powered from the surface. Same thing with data. All kinds of devices and services can be attached to sensors on the technicians. You plug in the devices into the top, they're all mated, and automatically the right device is connected with the right service module. Here's an example of our system being used in a wreck dive. People say, well, how can you do this in a penetration dive? Here's a very short video that shows how that's done very effectively because of the smallness and flexibility of our umbilical.
Test, test. I can hear you. I can hear you. All right. Thank you. Going into the engine room. Heading into the engine room. 10 feet. As you can see, it's just like the fire hose. I'm going to take about another 10 feet. Quite a bit of silk down here. 10 feet. Thank you. You have to watch where you're going. Air is good. You're at 2100. 2100. Outstanding. Oh, this is the boiler. Yep, boiler. Gotta watch the door. It's loose. See if I can see the stacks. Oh, there's the stacks, gentlemen. That was a weird breath. How you doing? Oh, doing fine. Blow bubbles up the stack. And I'm gonna enter the downstairs cabin area. Alright. You're at 35 on your new tank. Switched over. Copy that. 35. 76 feet. 52 degrees. I'm about 6 miles in. Oh, look at that catfish. That's a big one. Here, kitty, kitty, kitty.
There we go. And let me skip there. And you can see working those environments, if you had to drag those big, huge, thick umbilicals, there's a extreme danger in terms of entrapment, and the difficulty of managing them becomes very simple with our umbilical. There's another element to our technology, which is a bailout system. Right now, for these divers, they have to have a bailout bottle, but it's on the side of the tank or on the side of their body. In the water, it's always pulling you off on your side. It's a big pain in the butt. Everybody hates it. We came up with a front-mounted bailout system. And so the umbilical line can connect right here to a first stage it goes in, or if you went down without the umbilical, it can be attached in an emergency situation from the front. The advantages of this are significant, and when divers get trapped, it's very serious. So here's an example of the system being used and doing a complete equipment ditch. He's going into a tunnel that's only 36 inches in diameter. So if he gets caught in there with his equipment, he's got no way right now of being able to get out of it. So we've sped this up. It's a 50-foot tunnel. He's done inside of there a complete equipment ditch without removing his mask. And now you can see he's exiting, left all his equipment behind, and is able to escape to the surface. With the current technology, that's impossible to do. It's a major safety feature. I'm going to show one other video coming up. And come on, there we get ahead. This is pool training. Let me start that. There we go. And this will show you actually how that was done, because this is demonstrating in a pool. First of all, 2 full face mask divers can buddy breathe. First time this has been able to be done, because they can take a hose off of their tank, connect it to the gas block in front, rotate the knob, and now the second diver is breathing off of the main tank of the first diver. That's never before been able to do, and that's the advantage of our front mounted system. Another is, this is how the perfect balance and trim. We mentioned the divers being pulled over on their sides, because this is at the 0 center of gravity. It's perfectly balanced in terms of underwater. And this is how that diver did that escape. It shows you how this was done. So the first thing he does is rotates the knob from the main tank in the back to the front tank. Now he's breathing on the front tank. Quick releases underneath, quick releases in the front, and then takes off his harness, which has got the main tank, gets rid of that. And then the last step, because that's where the entanglement would be, he disconnects the main tank, and now he's able to ditch everything, and you can do that in a confined space. So those are major innovations. This is the same system being done now at 80 foot inside of the engine room of a sunken shipwreck. And this will show you how much air and the advantages of this. He's simulating that he's caught, he's running out of air, he's going to be able to do a complete equipment ditch and then work his way out of the shipwreck. If he didn't have this ability, he would not be able to escape. So he takes the system, he works his way out of the wreck, and the importance is you cannot ascend rapidly without incurring some significant health problems. So he's got enough air that he can swim horizontally over to the ascent line, which is the safest way to come up. He's coming up from 80 feet at a normal ascent rate, which is about 30 feet per minute. And then all divers have got to stop at 15 feet and do a 3-minute safety stop. And so he's got plenty of air to be able to do that safely. And after he's done that and done his safety stop, obviously we're cutting through this section by section. There, he's just under the surface, and after he completes that, then he's able to make it all the way up and out. And the last part of our technology, we've been able to make it so our umbilical connects directly with the main tank, because in some instances, the divers can't have this in front. If they're working in swift water, rivers, they have to have their belly to the bottom. They don't want the tank in front. So that umbilical system with all the advantages can now be connected directly to the tank and refill that tank in real time. So just to summarize, our technology is applicable in all these markets: first responders, commercial inland mesh, all of your military branches, renewable energy, tidal farms, all the maintenance and the structures, scientific, classrooms, scientific divers being able to do their work and in real time communicate bidirectionally with kids in classrooms, so that the kids in the classroom can see what the diver is doing, the scientist is doing, in real time ask him, well, tell us about that fish, that's coral. And those kids can be halfway on the other side of the planet while the diver is doing his work. Then you've got all your infrastructure, ship husbandry, and EOD. So this is the final image of all of the current technology as it is. This will grow and develop and expand it as other third parties come in and attach and make their technologies deliverable to our all these people who work in these extreme environments. So that's basically it. We can switch over. There we go. Thank you. I appreciate it.
Thank you, Bill. Wow, that lot of applications. Lot of
Yes.
applications. You know, with all the shipwreck footage, if Gordon Lightfoot would have recorded the wreck of the Edmund Fitzgerald.
Yeah, you're exactly right.
30 years later, he could have used all of your footage for the music video.
That's a great song. It's a great song.
It sure is. Really fascinating. How about what about like organizations like the American Red Cross or some of those types of disaster recovery people, FEMA, for instance? How about that?
Yes. Our biggest markets, I showed the underwater because it tends to be more interesting for people, but our biggest markets are all the terrestrial markets. It is your hazmat, confined hazmat. In the U.S. alone, there are 45,000 hazmat instances every year, just the U.S., and we're only 5% of the world's population. What you've got is all of your municipal infrastructure, water mains, sewer mains, utility systems, all of the military in terms of ship husbandry. any industrial complex that makes any hazmat material, and virtually every material is a hazmat material. All of the pipelines, the containers that they make this, those are all maintained and inspected on a regular basis by humans who go into those environments,
Right.
completely self-contained. And that includes all, in the US alone, one company, GATX, has 60,000 railroad tank cars that have to be inspected and cleaned. We've got 600,000 bridges over water. Every village has a potable water tower or water containment.
Yep.
And so it's one of these, so it's all of your hazmat, your first responders, search and recovery, all these instances that are on the terrestrial market is gigantic. The underwater market really is a subset of that. And you're exactly right.
Well, thank you. Very informative. Thanks for participating today, and continued success, and best of luck in the future. Great job.
Thank you very much. And I appreciate being invited and having the opportunity. I've enjoyed this.